Yes. Thank you for joining in. So, good afternoon, everyone. Uh, how was the assignment of GCD? Is there any difficulty there? Anyone have some problem with the assignment? Anything to discuss about it?
I want to ask,
Cool.
there are some like code that if we put in, it doesn't affect anything. Is it okay?
What do you mean by that?
Uh, when I when I tried the code with break, like the last one, blah 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 print and then break, uh, and
Because
without
you
break,
already written, right? You already
yes.
written, then there is no need to have break.
So it doesn't cause anything, right?
It will
If
not go there, yeah.
okay.
Okay, it will not go there anyway. So you can also use the debugging in Spider to check, okay, whether it will go there or not. Okay, so it doesn't cost you anything, but at the same time, you probably want to remove that so that your code become clearer. Okay. Okay. Is there anything else that you want to discuss? Is there any difficulty? Okay. Is Billy here? No. Darin, you
He
have
is
any
having
problem?
yes, Billy having problem with joining because he tried the link and it doesn't go in. So he is trying to
I'm
join
here. I'm
again.
here.
Oh,
Oh, there.
I'm. It's I can do it using my phone, but with laptop it's invalid. I don't know why.
I don't know. That's strange. Okay, so you can join in. Billy, I return your assignment because it's wrong. So please fix it. Okay.
Okay, sir.
And
Thank you.
Darin, you haven't submitted anything yet.
Yeah, because my laptop still not ready yet.
Okay, try to find other computer. You
Yeah,
can also go to the campus if you need a computer.
okay.
Okay, there is a computer lab there that you can ask. Right? Uh, okay. Uh, okay. So today we discuss a few things. Okay. First is the modulo operation. Modulo operation is the reminder operation, right? So if you have a division, right? After one number is divided by another, then you can see the remainder. For example, yeah, 5 divided by 2, right? The quotient, the result is 2, right? With remainder 1. So then we will say 5 mod 2 is 1. The same thing with 9 divided by 3, the quotient is 3, the remainder is 0. Okay? So mod operation will return the remainder of a division. So the remainder is always integer. So in that case, mod operation produce integer. Okay. So why mod operation is important? Because it can be used to model a cyclical pattern. Okay. So now I want you to create in Excel. Okay. You can open Excel and say you have a sequence from number from actually from 1, eh? Not from 0. Say from 1 to 31. Okay. So try to make from 1 to 31. Okay. And then assign the day in the week. Day in the week is Monday, Tuesday until Sunday. Okay. So earlier I put 0. So something like this. So you can use modulo operation for this purpose. My question is, can you do it? Okay, you open Excel and then try to create day in a week. Something like this. So if you have number 0, for example, become Sunday, yeah? 1 become Monday, and so on. Okay, so in Excel, you just use this way. Okay, so say you have number, so you plus 1, okay, and then you take the modulo operation of the column A plus 1, okay, and then for the day, you just make a lookup table like this. Okay, 1 to 7, okay, and you can put Sunday until Saturday. Then you're supposed to get this column C. When you do it, once you finish, you share your screen.
Sir, for the number, why is it starting with 0?
Oh, it's up to you. You can start with 1, start with 2. Okay. So the number of the day in a month is 1 to 31. So probably you should start with 1, not 0. Anyone who finished first will get the recitation of the day. Okay. But you need to show your screen.
Oh, sir, I done it. Can I share?
Oh, okay, share.
This one, sir. 1 is Sunday, 2 is Monday, and this is my formula.
Super. Okay.
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 Thank
Super.
you, sir.
Thank you. Okay. So, how about the others? Is there any problem? Anyone have difficulty? If you have difficulty, you share your screen. Stephen, Darin, Billy.
Sorry, I didn't listen because I was freezing to switch to my laptop. So I didn't know what you told us to do. Sorry.
So, Billy, you need to create the day of the week. Okay, day of the week, Monday, Tuesday, until Sunday again, right? Repeatedly, okay, based on any number, sequence of numbers. So the number is up to you, from 0, from 2 is up to you. So, but you need to make it into sequence of days. So knowing that the number, okay, we want to know the day of the week. Say from 1 to 31.
I don't understand the VLOOKUP.
Oh, you don't understand the VLOOKUP. Okay, wait a minute. Did you learn Excel already? Spreadsheet?
No.
No, okay, sorry. That means next semester. Okay, VLOOKUP is basically to look at a table. Okay, so given the table, that is the VLOOKUP, and given the value, then you will search. VLOOKUP will look into the table of that value in the first column. Okay, and then it will search for the next column K, for example. You need to give what column K mean. For example, K is 1, first column, K is 2, second column, right? And K is 3 is third column of the lookup table. Okay, so in that example a while ago, where is the lookup table? Here is the lookup table, right? So VLOOKUP, for example, here C2, okay? VLOOKUP B2 LUT is the lookup table here. Okay. LUT is column E and F, right? And then 2 means the second column. It will return the second column. Okay. So B2 is the value that you want to know, which is the modulo in here. And then it will search for the value in the modulo to become Monday to Saturday or Sunday to Saturday. Can you make it, Neville?
I only got 1 to 7, and then the rest is an A.
Okay, you share your screen. We will discuss about it. Oh, okay. Can I see the? Oh, okay. That one, because your lookup table is from G4, right? Supposed to be. No, your lookup table is from G4 until G10. Okay, now let's see. Your lookup table is supposed to be G4 until G10, but if you want to copy, you need to put $string, yeah, so you select that. You put $string in G and then put $string in 4. You put $string in H. Before H, then you put $string, and then 10. You put $string. Okay, enter. Okay, then you copy down. Okay, you got it. Very good.
Good.
Okay. Yeah. Oh, anyone else have problem? You feel? Jocelyn, Billy, Darin, Stephen, Tamara, Matthew?
No, sir.
No. Okay,
No,
cool.
sir.
Very good, very good. Real, yeah, no problem, okay? So let's continue then if you don't have problem. Last meeting, including your assignment, is about greatest common divisor, right? So our algorithm is using this flow chart, okay? If you use number theory, this flow chart can be put, this flow chart can be put into another technique, yeah? In numbers theory based on mathematics, we can use modulus, okay? So in Python, if you want to use modulus, this is the code, okay? Line 4 in here is the modulus, A modulus B. R in here is the remainder, okay? That's why you learn about modulus, okay? So if you want to use this code, all you need to do is to copy and paste this and then run it in Python. Huh? So look at the code here. Is we use while loop, right? And then it has break. So if not R, what's that? What does it mean? If not R here. If not R, R in here can be any numbers, right? So if R is any number other than 0, okay, any number other than 0, it will continue. If not 0, if R is actually 0, it will break. If not R is certain value, okay, that is true, it will break. Okay, so another technique is to use what is called recursion. Okay, recursion. What's the difference between recursion and iteration? In the iteration, you will see while loop here, while something something and then break. Okay, in the in the recursion, you don't see the while loop, right? You don't see the while loop, but what make it repeated, okay, is this. What make it repeated is actually the function will call itself. So you will see here, this is the name of the function, and then it will call itself. Okay, so when the function call itself is called recursion. So the result will be the same, okay, but this is different way to solve a problem. So in Python, you can have many ways to solve one problem. Okay? As long as the result is the same, it doesn't really matter. Okay, so now you can try this, copy and paste, and then run it, both of them. Yeah. Okay, this is another problem already. So can you try in Python? You use iteration and you use recursion. All you need to do is just copy and paste, run.
Is it okay to use spiders?
Yeah, okay to use spider, but use different name, okay? For example, GCD1, GCD2. You can modify into two functions. Does it work?
Which side is it again? The code.
The code is in the slide. The slide is in
Yeah. Yes, which slide? Which what number?
Page number. I think page number 42 and 43. Sorry, 40, 41 and 42. "41" is the iteration, and then 42 is the recursion. So if you can you do using Spider so that you can debug? Okay, create new two files, one for each function.
Sir,
Mhm.
the 40 is the implementation of find max.
Sorry, before that.
Before that, still find max also.
Really?
It's in intro computer science, like the slide name.
I think so. Still introduction to computer science. Oh yeah, okay. So this is the old slide. Oh no. Okay, that means okay. I will just put this code in the chat that you can use. This is the source of the code. Can you check? Oh, this is the find max. Oh, this is I make it by myself. Okay. Anyway, so in that case, let's do the find max then. Okay, let's do the find max. It's the same thing. So the find max, the problem is something like this. Okay. So given the list of positive numbers, you need to return the largest number in the list. Okay. So given the L is a list of positive numbers, so of course it must contain at least one number. Okay. The output is number n, which is the largest number in the list. Okay. So the iterative algorithm is you set the max to 0 for each x in the list L compared to the max. Okay. If x is larger, set max to x. Okay. After you do all, then the max, now the set of the largest number in the list. Okay. So in Python implementation, it's something like this. Right. So first you put the max to 0, and then for x in L is the list. Okay. Now, if x is larger than max, with this max that you put as 0 a while ago, then copy x to max. Okay. After you loop all, then return the max. Okay. The recursive algorithm is something like this. So, if L is length of 1, return the first item of L, right? So now you first set V1 to the first item of L, and then you set V2 to the output of performing find max on the rest of L. Okay, now if V1 is larger than V2, return V1. Otherwise, return V2. So if we implement this in Python, we'll go something like this. Okay, so again, if the length of L is 1, so length in the command in Python is length of L equal 1, return L0. That means return the first list of L. Yeah? And then V1 is equal to L0, so set the V1 is to the first item of L, right? And then set V2 to the output of performing Vmax on the rest of L, that means here. Okay. So V2 equal to find max recursive. You see, this is exactly the same name, but different value. It is the first one you already put it out to V1. So then you use the rest of the list. Okay. And then you check, okay, if V1 is larger than V2, return V1, otherwise return V2. Okay. So all you need to do is copy and paste of these two Python implementation. So this is find max iteration, and this is find max recursion. Okay. So after that, you answer this question. All you need to do is just copy and paste. Put it into two pages. Or if you put it in the same page, you need to keep different name. So this is the practice. So copy and paste the Python implementation. Now you create your own data. It's up to you to put L. And then you run the code, and then you tell me which one is faster, iterative or recursive.
Sorry, sir. There's a person later in the house.
Copy and paste the find marks, both iterative and recursive, and then test which one is faster.
How to test it, sir?
Okay.
Can I share?
Yeah, sure.
Okay. So like this, right?
Okay, this is the, okay, good. So, how do you test that, Billy?
I don't know.
You put the value to L first.
So
L equal bracket, block bracket. No, block bracket. Yes, okay. So you put any numbers, 1, 2, 3, or comma, yeah? Separated by comma.
like this?
Yeah, you can put any numbers. You can put any list. So 10, 110, and then going down to 2, and so on.
And then
Next, you need to put the find max iter L. That is how you will call. So you copy the first line, but without def, without colon. Okay, copy down. Control V. Okay, you run. Is it working? Oh, you need to print that. Okay, you give name, for example, what is the name? You can put name X or B or whatever.
this.
The return value of find max, you need to put it into a variable, or you can directly print that value. In line 9.
Yes.
Line 9, in the beginning of line 9. Okay, so you put X equal. Okay, good. Now in line 10, you need to print that. X, print X. Okay.
Like this.
Then you can run. Oh, you get 10. Is that correct?
The max value, yes.
The max value is 10. Oh, you can change the L.
Okay.
So you can put negative value if you want. Okay, and
But
is that correct? 1 is the maximum there.
yes.
Oh, you can put more lists than that. So you can put 1 minus 5 minus 3, 7 minus 77. For example, and what else? Any number that you like. Okay, so what is the max?
1000.
Is that correct?
Yes. Yes.
Correct. Good. So now you test the second one.
So wait, the same, the way to do it.
Oh, yeah, the same, but
Okay.
you just copy if you want, so that
Yeah.
you can test. So you copy. Okay. Okay.
Oh.
Oh, the function is different, right?
Oh yes.
Because you give different name there up in line 1. So you need to put exactly the same as that. Okay, and then you run. Will you get the same result? Oh, you get the same
Yes.
result. Okay, so next question is, how do you test the which one is faster? Okay.
First maybe.
So you check the Google, okay?
Okay. Okay, thank you, sir.
Oh, you check Google how to test my code is faster, which code is faster, okay? So who else? Matthew, finish?
Yes, sir. Finish.
Oh, so for you, can you find minimum rather than maximum?
Yes, I can. I'll try.
Okay. Darin, can you share your screen? Are you using mobile? Okay. So good. Good. So can you run that? Oh, there is a problem. What is the problem there? Indentation error. Your code is not finished yet. Right? If len L equal 1, then what? If len L equal 1, then return 0. That one need to indent. You need to put tab. Yeah, in that line with the cursor, you need to put tab. Or you can put the space 1, 2, 3. That is the same thing.
Why my keyboard cannot be used when I share screen?
Okay, you can put space therein.
Okay, I'll try.
Okay.
Okay, then
Indentation error mean you did not put space or tab.
in front of the return one.
I cannot hear you. What?
In front of the return.
Can you share your screen so that I know what you're saying?
Put the space in front of the return.
The space in front of the return, correct. Look at the slide. The space must be correct, okay? Exactly
Okay.
as the slide. The space matter there. Can you check the slide? There is a space, right? After def, you have space. After if, you have space, right?
Like this one, right?
Yes, but after def, you need to have space also, all of that. After if, you need to have space. Okay. Go exactly the same as the one that in the slide. And the space must be exactly the same. That's why we use tab rather than space. You see, after def, we have space. Can you see?
Okay.
In the second line, the first line is def, right? That's definition of the function. And then if, the first if, you need to have space. 1, 2, 3. The same as written. Okay, and then in the return, you need to have space. In the line 3. Okay, 1, 2, 3 again. 2, 3, okay. And then in V1, you need to have space. Should be exactly the same as if V1 equal L0. Okay, the same thing with V2. Okay, and then the else. In the else, you need to have space, the same as if. And then the last one, return, the same as return. Okay, this one is fine. Run this, the arrow. Okay, how to run, Darin? You need to give the value first, okay? So you give next code, plus next code. Okay, and then L equal L. The list equal, so you make a list, any number that you want. So you put a block bracket. Better to use block bracket rather than the list. Okay, any number. Oh, you can put more numbers there. Yeah, okay, one more probably. Okay. Minus, you can put minus if you want. And then close it. Close the bracket. You run that find mark L, yeah.
So I add another code.
Yeah, you can add another code. That's another line. So find mark L. Oh, exactly the same as earlier, the one that you defined there. Find max underscore, right? Using underscore, right? No, without def. You just call. Def is definition. You need to define. So if you want to call, you just call the function name. Okay, find mark L. Close it. Okay, run. No need colon. Oh, you got that. Is that correct? That is the max?
Yes.
Oh, good. You run it. Okay, go ahead with the second one, huh? The recursion. Then you compare. Very good, Darin. So, who else?
Sir, I have finished the minimum value.
Oh, okay. You show me and then run.
Huh?
You
Okay,
run.
sir.
Show me.
This. Wait, I think it's crashing. Awesome. Yeah.
Can you see Matthew's screen?
No.
Not yet.
Not yet.
So I want to ask.
Oh, cool.
For the what is I don't the implementation. Well, I don't get the
Which one?
Implementation.
The implementation of iteration or recursion?
And iterative iteration.
Like the iterative.
Uh,
Okay.
Can I share?
Yeah, sure. Iterative is the easiest. So
When I run this one,
okay.
I got 44.
What? Oh, you got 44.
But when I run this, I got 8.
When you run this, you get. Oh, what is this? First, you put max equals 0, and then if x is larger than max, max equal x, and then return max. So you did not return the max. Okay. I think your problem is your return max too much stub, right? Your return max is too much stub because you need to put it the same line with 4. Yes. Okay, run again.
Thank you.
Is that correct? Now?
Yes.
Okay, very good. So, okay, I will give you assignment. Okay, to draw the flow chart. Okay, to draw the flow chart of that code. Oh, before I give you assignment, if anyone can show that, we will not have assignment. Okay, you need to draw that flow chart. A challenge. Okay, so you draw by hand. There's no problem. So you draw the flow chart of that iteration that Kenneth just showed.
Sir, only the iteration, sir.
And only the iteration, of course. The recursion flowchart is difficult. Okay, the iteration is easy. So you should be able to do. Right? So draw the flowchart of max. Find max. And this is interesting. Why? Because you need to know the algorithm behind that, right? Why it work? Why it doesn't work? At least you need to know the iteration. If you don't know the recursion, I can understand, but the iteration should be able to do. Okay. Newfield, you have problem?
No, sir. No.
No.
Still
Wow.
trying.
Still trying. Okay. Billy.
Oh, what, sir?
What? Find max. Can you show the flow chart?
Oh, I didn't try, sir. Because okay.
Sia, you want to try? Draw the flow
No,
chart.
sir.
Oh. If not, I will give you assignment.
I'll wait for Matthew, sir.
Wait for Matthew. Come on. This is don't rely on other people. Okay, this is like basic literacy. for you to do a programming. Yeah. You should be able to do it. Okay. It's not in the slide. Okay, so go. In the flow chart, what do you need to put first? Any flow chart start with?
The start one,
Yeah,
the
start.
diagonal.
Okay, no, you put start. And then where is that? In the code, what is that? The first thing to do is to put what?
Find the maximum.
Max equals 0. No, the definition you can just ignore in the flowchart. Okay, max equals 0. That is the first part. And then what else? How do you draw the flowchart of that? And then you remember we practiced GCD last meeting, right? So what you will do? You will do the diamond.
Yes or no.
The diamond, okay? You will draw the diamond telling if x equal to max. So how do you put the 4x in L into a flowchart? Okay. The loop is clearly come back, right? So there is a come back arrow. Okay.
Sir,
Ah,
I've done, sir.
okay, show Matthew.
This will. It's like a paper. I don't know if you can see it.
No problem.
Oh,
You
wait, let me turn off.
the paper is fine.
This is the full chart.
Can
But
anyone
I
see?
didn't do the return max. I haven't done the return max.
Okay, you did not.
This
What is that? Max equals 0 and then x is larger than?
max. If yes, then max equal x. Then return to the this
Yeah,
part again.
almost correct. But you see that there is an x, right?
Hmm.
Larger than max. So what is x? From
Oh, yeah.
where x come
Wait.
from, right? No.
Okay. Wait, sir. Wait.
Almost. That almost correct. Okay. Just missing one. What is x? So you need to put the input L. In the beginning, you need to have input of L. Okay. Then you can have a question of if x in L. So there is actually inside that loop there is a question also the diamond if x in L. Okay. If yes, then go down. That is the one that you already drew. Okay.
Done, sir.
Done. Okay. Oh, you want to draw it in what is that? Whiteboard so that everyone can see also.
Oh, my pen is missing. I cannot. Oh, maybe I can go using mouse.
Okay, you can try.
Okay. Wait. Let me do.
Okay. So everyone else try to do. Okay. It's a challenge.
Sir, no homework yet, sir. So.
No homework. If you can finish, no homework because everyone can see already the answer, right? our class is recorded in YouTube, so no homework of that problem, okay? Maybe there's homework of other problem. Anyone else want to show? Oh, which one is faster? Recursion or iterative in this case? How do you do that? Okay, so let me check. So you can use time. This is one way. Okay, there are many ways in Python. Where is my slide? Here it is. There. So you can import time. Okay, you can import time and then you can start time. Start equal time. Okay, so you set the repetition and then you create a repetition. Okay, of say, how many is this? 1 million, for example. Okay, you repeat 1 million times, okay, and then at the end, you also put n equal to time, and then you minus the start with the end. Okay, so all of this you just copy, and then you start the time, right? And then you repeat the same thing with the number of repetition, which is 1 million, but this time you use recursion. Okay, and then you check which one is faster. Do you have this in your slide?
Yes.
Okay, cool. So I can stop sharing. Because the computer run very fast, right? That's why you need to repeat 1 million times so that you can see the value. Right? You got it or not?
Sir, for the drawing, can I just share screen and annotate, sir?
Yes, go.
Okay. Wait. Is it visible?
Yeah, you can put input, okay? Input of L.
Wait.
Okay.
This is the input.
Yeah, input.
L
Okay, good.
input. And then after that, I check the condition is X in L.
You need to put
In L with
before that you need to put max equals 0.
max. I put that after this, sir.
If you put that after that, will not work, isn't it? It will not work if you put max up inside there.
Oh,
Okay.
so first.
Yes.
Okay.
When you put the max equals 0 inside the loop, it will not work.
max equal 0. This is the square.
Yes.
After that, this
Okay. You
will
ask
be x in L.
x in L. Okay.
X
In
in
L.
L.
Okay. That one you put diamond. Okay. So any diamond will have yes and no. Okay.
If yes,
If yes,
it will go to the loop. If yes,
okay.
it will check the
If yes,
if
what? If yes, you ask again.
x again.
Yeah. If x is larger than max.
Yeah, if x larger than max,
Mm-hmm.
this is diamond.
Yes. Again, if
And
yes.
then if yes,
If yes, what?
if yes, max equal x.
Very good. Okay. If yes,
And
okay. Max equal x
max
equal x.
x.
Okay.
Yeah.
And then
If
now for every diamond you will have no also n.
mm, this is if no,
If no, what?
if no, we go to this part. Check it again. This.
Okay.
And then if this is a no,
No.
this is wait. If this is no,
What you will do if no? Or you can go into the
return.
left at the bottom if no space.
Oh yeah. If no, I'm going to return max. Okay. Return
Return.
max.
You return max there.
Yes, suppose
How about down there? Max equal x and then what?
max. Oh yeah. After this, max equal x, and then it go again to this x in L. Okay. Correct.
If x is not in L, so no more x, then return max. Okay, you try this. Is that correct or not? What do you think?
Wait.
Hmm. So what happened here is when you put assignment, okay? When you put assignment, I will draw different color, okay? No.
Mm.
When you put assignment max equals 0, what does it mean? Anyone? A variable
Oh
here
yeah.
is represent a box, okay? So say you have a box, okay? The name of the box is max. When you put 0, that means you put inside here 0. Okay? The same thing with this. When you put like this, max equal x. Okay? Whatever x it is, okay, that is the one that you put inside. So x, for example, x equal 80, right? So that 80 will be put inside that box named max. So when you return the max, you return, you put it out, what is the inside that box. So the meaning of variable, okay, is basically a box to store your value. Do you get it or not? Yeah, thank you, Matthew.
It's correct or not, sir?
Yeah, it's correct.
Oh, okay. Thank you, sir.
Okay. Ah, is there any question? So far, so good. Can you do it? No, Billy? Tell me what is your problem. Go, Kenneth.
The return is in diamond or square? Yeah, or
The
rectangle.
return is what?
In shape of diamond or rectangle.
The return is not the diamond. So the return is the last one. So meaning that is output. Return means output. You print. Okay. So my question is like this. A while ago, Kenneth, you put the return inside that loop, right? Why it doesn't work? If you can think about the loop, and then the return is inside the loop, why it doesn't work? And what happens if the return is actually outside the loop, right? So why the return must be outside the loop? Can you think of that?
Yes.
Okay, let me show you the. This is the one, right? A while ago, what Kenneth did mistakenly is to put this return marks there, okay? The same as this line. That means the return mark, if x is larger than max, max equal x, and then it will return max. That's why it doesn't work, right? So the question is, what is actually going on here? Okay. First, in this implementation, first you, oops. Well, okay, the pen. So first you will input L, right? For example, L equal, what do you want? 880 minus 1, for example. Huh? So, and then it will enter here, max equals 0. So M equals 0, right? After that, we'll go here, we'll ask X in L. It will define X in L. That means what? X now equal 8. Okay. Where is X coming from? That is when you have 4X in L, that's it. What it means is it will take one by one from this loop, list. Okay. First, it will take the first number there, which is 8. So then X is equal to 8, right? And then it will take, if X larger than max, X is 8, max is 0. X larger than max, yes or no? 8 is 0, 8, X is 8, M is, max is 0, right? This is max. Max is 0, right? At this point. So, is it X larger than max? No, right? If no, what you will do? The program will come back to the loop again, okay? It will take the second number, which is 80 here. So X is now 80. right? Oh, sorry. If x is larger than max, max is 0, x is 8, then max now become 8, right? Because max equal x. That means max equal 8. Okay, and then it will come back to the second loop, come back to line 3. It will take x now become 80. Okay, and then it will ask again, if x larger than max, what is max? Max was 8. Okay, x is 80. 80 is larger than 8. Yes, so it will go to line 5. Right, so max now become how much? 80.
80.
Okay, and then finish, right? And then come back to the loop again with this line 3 again. Now x is now become minus 1. Okay, and then asking if x is larger than max, max is 80, minus 1 is not larger than 80, so it just skip that. So it will skip and then go back to line 3 again. But there is no more. There is no more member of L. So and then come back to line 6. It will return max. What is max at this point? 80. So it will return max as 80. That is how the program works. Is it clear?
I want to ask. So the max is cannot identify negative. Like no, what I mean is the number is all negative. The max is equal to 0, right?
You can try. Okay.
Yes, I already tried it to 0.
It will go to 0. Oh yeah, because the initially you set up as max equals 0, right? Oh, so how to solve that problem? Oh, very good.
Just L0.
Huh?
Take the first item of the list. Not instead of max equals 0, we take the first item of the list and compare it to the rest of the items.
Oh, that is one problem. Okay. But is there any way better than that? Because, for example, if the list is nothing, okay, if the list is empty, it will create error your code, Matthew. Right? So, is there any way better than that? So, initially, your max, okay, must be put a very large negative number. If you want to find maximum, initially you set the max as very large negative number. If you want to find minimum, initially your minimum must be set as very large positive number. The other way around. Okay. Oh, try. Okay. Set that very large negative number. So, for example, negative, what is the very large negative number that you want to set? You can assume anything. For example, minus negative, or minus 10,000 or minus 1 million is up to you. Okay. Can you make it, Kenneth? Minus 1 million.
Yes, I already tried it and it can.
It works.
Yes.
It can take negative now, but as long as your negative number is not less than the large number that you set initially. Okay. Good. Is there any other question? Yeah. Excellent question, Kenneth.
Sir, I want to ask, like, this when we find the maximum and minimum, we loop it into one by one, right?
Correct.
Is there any way of other than looping one by one? Like,
Good
I don't
question.
know.
So, is there any way looking rather than looking one by one? Oh. Yes, there are many other ways. Okay, one way is to sort first, and then you just take the largest at the end, right? So that is probably better. If your sorting algorithm is faster than, if you find max in here is looking one by one, right? That means the runtime is linear, correct? Linear mean, for example, you have 1 million members of the list. It will take 1 million seconds if one run is 1 second, right? If one run is 1/1000, that it will take 1000 seconds, like that. Okay, so it's linear. But if you sort it first, right, it will take, say, for example, the sort time is actually n log n, for example. Then it becomes very short, right? And then you just take the last number in the sorted array. Surely it becomes max. So there are many ways to do an algorithm, okay? In fact,
Sir,
people will start to find how to do it faster and better. Okay. Two important algorithm is to sort and to search. Okay, there is a algorithm called quick sort. You can search in Google. Okay, and there is an algorithm called binary search. After you sort, it will take very fast to get the searching the number, the location of the number. Okay.
And sir, if we want to find the minimum, we just have to change it into MIN.
Okay, okay. Billy, your assignment ya, find the minimum, okay?
Oh, okay.
Don't copy Matthew, okay? It's very good challenge so that you can practice to do on your own. Okay, and this is really very simple algorithm anyway, right? So
yes, sir, I want to ask the sorted function in Python, which algorithm it uses?
I don't know. I did not see
Oh,
the inside. So if you want to see the inside, you go into the source code and then check. The source code is open, right? So you go inside and then you check on your own. Right. But it's quite a good question. Okay. So out of curiosity, okay, you can check what is inside the Python. And after you check inside and you found out that this is not optimized, then you can optimize it and then you can contribute there. Then your name will be on it, right? So, but I don't believe it is not optimized because there's so millions of people are looking at it. Okay, but who knows, right? No. So you can take your chance. Okay. Okay, go ahead. What else? Tamara, Joyce, is there any question? Which one is faster? A recursive or iteration?
iteration.
Iteration.
Iteration is faster, right? By the factor of 3, isn't it? Like 3 times faster in this case. Yeah? Okay. Let's go to the next topic. Oh, the next topic is about data structure. Okay. I will show the data structure. So we have discussed algorithm, right? So now I want to discuss about data structure, okay? Data structure is data organization, management, storage format that enable efficient access and modification. Okay, there are many data structure. Okay, so basically data structure is a collection of data values and the relationship among them. Okay, together with the function or operation that can be applied to that data. So that is data structure. So I will not discuss all data structure here. I will just mention only a few, okay, that probably you already know. So one is array. You already get the list, right, a while ago. So array is a collection of elements, okay. It's identified by at least one array index. So array in Python is something like this. It will have 0, 1, 2, 3. So these are the storage, okay. Each block here represent one number or one text. Okay, and there's a key, right? The key is an index. So usually index is start with 0. Okay, so 0, 1, 2, 3. So if you put array 0, that means it will come out with the first number, the value of this box. If you say the name of the array is L, okay, so then I will say L5. What is this? If I said L5, it will come out the value that we store inside this L5. Yes. Okay. So another way is to create the key, not numbers, not index like this, but you can also put as any string or any numbers. The key, okay, can be put as values. So you can also create 2D or 3D ND array. Okay, so 2D array is 2D, two-dimensional array is basically a matrix. Consists of row and column, right? So again, the rows start from 0, the columns start from 0 also. Okay, so in this case, I will say, for example, this is M. Okay, M01. What is the value of M01 in this case?
A.
Okay, that is this one. Right? This is the row and this is the column. You see, array. So another data structure that is famous is called linked list. Linked list is a linear collection of nodes, something like this. So in linked list, there is a node. Okay, there is a value inside that node and a reference or a link to the next node in the sequence. Okay, linked list data structure is like this. Okay, so you store the value inside the node. Okay, and then each node will point to another node, the next node. Okay. So linked list with 3 objects, 3 nodes is something like this. Okay, so you can have the point, the arrow here is represent the pointer. Okay, pointer is the memory address of the next node. Okay. Another data structure is called hash table. Hash table, what is hash table? Hash table is a data structure that uses special hash function to map a given value to a particular key. Okay, so what is hash function? Hash function is a function that will assign unique bucket. Okay, so for example here, the key is John Smith. Okay, and then using hash function, okay, for example, it will assign to a certain bucket. So using hash table, okay, it will become very efficient in terms of searching, insert, and delete because it's O1. That means very fast. Okay, the worst case is ON. But in terms of the space, it takes a lot of space, which is ON. Okay, so now this is an example of hashing function. So the idea of hashing function is to distribute the entries, okay, which is the key or the value pair, across an array of buckets. So given a key, so there's an algorithm, you don't need to know what is the algorithm inside. There's an algorithm to compute the index that suggests where the entry can be found. So if you know the key, okay, it will give you the index. So example of an algorithm is just simply like this. Hash mode array size. This is one of the simplest example. Okay. Now you have heard about blockchain, right? Okay. Nowadays people are talking about blockchain. Okay. Actually, blockchain in computer science, blockchain is nothing else just a single linked list. Okay. So each block here will consist of hash value. So implementation of blockchain is basically linked list with hash value. Okay, so the major difference between blockchain and linked list is you cannot remove and add the block in the middle of the chain. Okay. Okay, until here, is there any question? This is another topic.
Sir,
Yeah, go.
how do you create linked list in Python?
Oh, you search Google. There is already
Oh,
library for that. Okay. You search Google. Very good question. Everything that you ask, if you can find in Google, don't ask me. Right? Okay. Oh, what else? New field. You keep laughing.
Yes, sir.
Yes.
No question, no question.
No question, no question, because you can ask Google. Right. So there is difference between the teachers in the past, before the internet exists, and now, where the internet exists, you know. The teacher in the past is an expert. The teacher now is just facilitator. It's impossible to win over Google, isn't it? Oh, okay. So we just facilitate, okay, and then give you certain curriculum so that you can learn by yourself. That is the most important part. Learning to learn is the most important part. That's why when you said, oh, I cannot do it because I need to search. That is a wrong idea. Why? Because you always search. Don't hesitate to search. Okay? Don't put in your mind that I don't like to search. That is not correct attitude. Okay? You always search. Even the most expert, okay, any programming language, including Python, okay, they will always still search. Say, who is the creator of Guido? Guido van Rossum. He will still search, you know. He is the creator of Python, right? Oh. So why? Simply because he knows Python, but he does not know all this module that created by millions of people. Correct? So it's impossible to know everything. So you search because there is a machine already can help us. Okay. Oh, Kenneth, did I answer your question? I don't want to search, Kenneth said. No, you need to search. Okay? Yeah, exactly that's. Programming is basically you search, you copy and paste, you improve, isn't it? You combine this and that, you get something new, isn't it? Hmm. And then when someone asked me, okay, oh no, this is a joke, but it can be real, okay? Oh, someone asked me to do a program, okay? And then they said, oh, I have this problem. Can you solve this problem? Yes, okay. Say, for example, oh, $100, say, okay? After we solve it just in 5 minutes, right? Oh, I thought $100 is 1 hour. This is only 5 minutes. Yes, right? The 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 solution, the code itself is just maybe less than $1, right? The knowledge behind to search, that is 99. Okay, the ability to search is important. That's my point. Okay. Because there is already there in Google does not mean when you search you will find the answer, right? Okay. Say you search and then you find it in Stack Overflow. There are so many answers. What you will do? Then what you will do is you try one by one, right? You check the rating, right? If the rating is high, probably that's the answer, and then you try. If it doesn't work, you search again, right? That's really what to do. Okay, don't hesitate to search. That's the most important part. Okay. In general, the data structure, do you understand the meaning of data structure? Matthew. The detail on the implementation you can search, okay? But the knowledge, the general knowledge, you're supposed to know. Okay, let's go to the next topic then. The next topic is theory of computation. So, what is theory of computation? Okay, theory of computation deal with what the problem can be solved of a model of computation using algorithm and how efficient they can be solved or to what degree, right? So, the theory of computation will deal with algorithm and data structure, both. Okay, and in fact, you can search here in Google. There is what is called Millennium Prize Problem. Can you search now? Okay, there are several problems that if you can solve these, okay, you will get $1 million. Okay, if you can solve one of these, any one of these, you will get $1 million. Okay, how much is $1 million in rupiah? 15 billion, right? You will get 15 billion rupiah. So, in the theory of computation, you will have what is called analysis of algorithm. Okay, so in the analysis of algorithm, okay, you will deal with what is called complexity of algorithm. What is that? Is the amount of time or storage or other resources that needed to execute an algorithm. Okay, so let's say we have two types of complexity. One is called time complexity, the other one is called space complexity. Time complexity is the number of steps taken in the algorithm. Space complexity is the number of storage location that the algorithm use. Okay. So for both, okay, time complexity and storage space complexity, you have what is called asymptotic function. Okay, so asymptotic function is a function, okay, to tell how the runtime or the space requirement will grow as the input of the size. Okay, the most important here for you to know is what is called big O notation. Okay, so big O notation. So O of X. So here is the chart of this X. Okay. So for example, ON, yeah, or ON square. So where is ON? The green here is ON, right? ON square, where is that? The red one here, right? And this is ON log N. So on the horizontal axis, you have N. N is the number of input size, okay? And you want to know which one will grow faster. Okay, ON is mean linear. This is the standard, right? So you will see here if the tangent, the curve is actually on the left hand side here, that means it will grow faster. The one that grow down here, it will grow slower. Okay, the best algorithm will have O1, the best one. So the purple down there or the magenta, O1. Okay, the next one is log N. That means your input size is N. Okay, the algorithm will solve it in log N. Okay, the next one is square root of N. Okay, so N is linear, it's kind of standard, right? But if you put your algorithm, okay, if you use an algorithm that is N square or N log N, okay, that is actually quite slower than linear. Okay, the worst is actually N factorial, the black one there. Okay, so this is from Wikipedia, you can check by yourself. Okay, O1 mean constant time. Okay, for example, in dictionary later in Python, when you want to search, okay, to get the value of a dictionary, that is O1, constant time. Okay, so ON is ON factorial. Okay, for example, to solve a TSP problem using brute force, okay, that is factorial problem. So you cannot solve it larger than 20 cities, okay, and so on. So you can check by yourself. This is the one in order of big O notation. So by knowing the big O notation, you can compare an algorithm, which one is faster. Okay, for example, binary search. What is the big O notation of binary search in this table? O log N. Okay, so that is quite fast, right? So how about using KD3?
Fractional power.
Yeah, fractional power here, right? Okay, so to sort, so you can search, okay? For example, if I want to use a merge sort, this is an algorithm name, right? If I want to use heap sort, okay, is it better or not? So you search there, okay? So there's thousands of or more than 10,000 of algorithm. We cannot even memorize all of this, but you can search, right? And then every time you search, what you will do, you will check the big O notation, okay, in terms of the space and in terms of the time. You see that? Then you can compare. Okay. Up to here, is there any question? So this is the way to do, right? You still search, but you know what to search, isn't it? So the class will give you guidance on what to search. Okay. So many information, so don't look at so many information. Look at only the big O notation of the time and space. And then you compare. How do you compare? Look at that table a while ago that we give, right? Is this clear or not? Should I give you a test? Okay, the test searching, okay? So, okay, find sorting algorithm, okay, tree sort algorithm, and then give the big O notation, runtime, the time complexity, and then compare which one is faster. Any tree sort algorithm. This is to sort a list. Okay. Just find tree. Okay. Sort algorithm, and then tell me which one is the fastest among the three that you list. No, everyone will get. We need to check this. Ability to search is important.
So we just search sorting algorithm.
Yes, you just search sorting algorithm. Very good. And then list three only. Okay, just list three. Any, yes, any, no problem. But you need to compare the three that you listed. Okay, which one first? Whoever first winning in terms of unique. So if someone already mentioned, you should not mention it again.
Sir, I've done, sir.
Okay, list it.
Selection sort, merge, and bubble sort. And
Okay.
the fastest is merge sort. The second is bubble sort, and the last is selection sort.
Oh, give the big O notation so that you can see. Can you share?
Okay. I haven't done the big O notation.
How do you know that this is faster?
I have done this quiz, and the first I've answered bubble sort, and it was false.
False, of course. Bubble sort is like the slowest. Okay, bubble sort is the slowest. So, but you need to know how do you know it's slowest? So you check the big O notation. Okay. So search any algorithm of sorting, and then sorting a list, and then tell me which one is the fastest among the three that you listed. But you need to give the proof. How do you give the proof? The big O notation. Karin, Leonard, Stephen, are you still there?
Yes, sir.
Oh, what is your answer?
Yes, sir. I'm still here, sir.
Oh. Why you are closing your video?
My background not
I'm in
good.
the restroom. Wait.
Go, anyone? Just
So
search, right?
the best one is quick shot.
Hmm?
Quick shot.
Mention the three. Mention the three. What are the three that you?
Quick. Does mean you have said quick shot.
Quick shot and
Quick shot is short, hip short,
hip shot,
and bucket shot.
bucket shot. Okay, so what is the bucket shot big O notation?
And plus K.
Hmm? Can you type or
And
can you
plus K.
share your screen so that we can see? So that everyone can also learn from you, right?
This.
Oh, okay. So you have this. Quick shot is what? What is the best? Can you share that?
Lock.
Hmm?
This like lock. Wait.
What is the meaning of best, average, and worst in here?
The time complexity the fastest.
Okay, so is quick shot actually the best? Really?
Not sure. Not sure.
Right? Maybe on average, yes. Right? So the three of them is say quick shot, merge shot, and team shot. On average, have n log n. Right? So all of that have n log n. Okay. But in terms of the worst case, actually quick shot is not better because you look at the worst case, the quick shot is actually n squared. Can you check the curve a while ago that n squared is actually worse than n log n?
So the best one is counting shot or hip shot. Hip shot maybe. No, because it is the same.
Depends on what do you mean by the best in here, okay? So if you are talking about the average, the quick shot is probably the best. The best, average, and worst, okay? It depends on the luck of the data that you put, okay? Right? If the data that you put have certain arrangement, okay, that actually need to do it one by one, okay, the quick shot probably will do worse, okay, which is actually n square. Okay. So in that case, merge shot is actually better. But in terms of the space, okay, in terms of the space, quick shot is the best, you see. Log n, right? But in terms of the space, hip shot compared to quick shot, which one is better?
In terms of time.
Space.
Space.
Hip shot and quick shot, which one is better in terms of the space?
Is it quick shot?
Which one is good?
Is it quick shot?
No. You need to know that O1 is the best.
Okay.
Okay? O1 is the best. Look at this curve here. This one. Can you click that? There. Oh, there is no O1, or probably this one. Is there any O1 here? There. Okay. O1 is this one. So this is the best. Okay. O1 and then log n and then n, right? So going here is the best. Going there is the worst. Okay. So at least you need to know
Okay.
how to read this chart, isn't it? Is it clear or not?
Sir, so best means like loading fastest or what? I don't know.
Two things. One is the space, the other one is the time. Okay? The time, the best time means the fastest, right? The worst time is the slowest. In terms of the space, the best space is the minimum space, right? In terms of the worst space, that is very large space.
So the best one requires small amount of space.
Both time and space.
Okay.
Okay. So the best algorithm require minimum amount of space and the best in terms of time, that is very fast. Okay. Now if you need to balance, okay, space and time, right? Okay, which one is more important for you, space or time? It depends on the context, right? So most of the time, usually time is more important than space. Okay? Maybe because the hard disk price is now cheaper, right? Okay? But there are certain problems that you need. The space here is the amount of memory also, not just the hard disk space. Okay, so the RAM, how much RAM that you need to do. For example, one of my thesis students right now having problem with their memory because the algorithm is actually have a space complexity that is very bad. Okay, so the time is okay, but the space is bad. Then they have problem with the memory problem. Okay. Okay. Any other question? What do you think? So tell me, what did you learn today? Billy, I learned nothing. Okay.
Learn a function of finding maximum value.
Okay, very good. Which one is best between iteration and recursion there?
Iteration simpler, I guess, the function.
Okay. And then, what else did you learn aside from finding maps? Did you learn about data structure? Did you learn about big O notation?
Oh, yes.
Yes. So can you find, Newfield, can you find the which one is the best big O notation?
I can try, sir. I'm search.
You still confused? Oh, Stephen, ON compared to O1, which one is better?
M compared to O1.
ON compared to O1.
Um, OM, I think.
No, O1 is the best, okay?
Okay.
Who else? Tamara,
Yes.
ON square compared to N log N, which one is better?
Which one?
N square, polynomial, compared to N log N.
N square is better.
No. No. Look at this curve. Which one is better?
Oh,
N
N
log
log N.
N compared to N square. Which one is better?
N log N.
Okay, N log N. Okay. So who else? Uh, Sia, log n compared to n log n, which one is better?
Log n.
Yeah, okay, very good. Just look at this curve, okay? Do you feel you can check the curve already?
Yes, sir.
Oh, good. N square compared to 2 exponent n, which one is better? You feel?
N square compared to
2 exponent n or n exponent 2, which one is better?
n component 2, n2.
Yeah, n2 is polynomial, quadratic, right?
Yes.
So 2 exponent n is exponential. Okay, so that is worse. Clear or not? Jocelyn, n compared to square root of n.
What is the first one?
On compared to O square root of n.
I think ON.
On compared to square root of n. Which one is better?
ON.
No.
Oh, square root of n, yeah.
Yeah. Look at this. Okay. This is On. Oops. Where is my curve? Right here. Okay. So this is On. Right. This is the On is green. The square root of On is here. So remember, going down here is the best. Okay. Going to the left is the worst. Okay, worst. Okay, this is best. Okay. Last, Tarin.
Yes.
On compared to n factorial. Linear compared to factorial, which one is better?
On compared to
N factorial.
factorial.
Which one is better? N is better, okay? So, clear, yeah? Very easy, right? If you get a quiz like that, you know how to answer, right?
Yes.
Yes, okay, good. So next meeting we have quiz. Until this topic, okay? From beginning until this topic. Okay, so thank you for today.
Okay, thank you.
Thank you.